The Centre of Physics at the Universities of Minho and Porto was originated from the fusion of two research centres, one at University of Minho and the other one at University of Porto. It comprises almost 8 integrated members with a PhD and involves a universe of almost 200 researchers and collaborators. The scientific activity of the centre is organized in 4 research lines. Line 1 is focused in optometry and vision sciences. Line 2 is dedicated to quantum materials and bio-nanostructures. Line 3 on functional and smart materials. And Line 4 dedicated to theoretical studies in quantum field theory, high energy physics, condensed matter theory, cosmology and quantum gravity. It is interesting to notice the complementarity between the different lines of research, which involve the ones with high intense laboratory activity like lines 1, 2 and 3, with more than 30 experimental laboratories where researchers perform their daily scientific activities. And theoretical research, which is performed in line 4 at the centre in Porto and partially done as well in line 2 at University of Minho. Since 2021, the centre is part of a new associated laboratory for materials and advanced technologies, which was named LabMet. It's quite exciting, the excellent research diversity of the centre and the way it interacts with society at large, as you will have the opportunity to realize in what follows.
Our group, with 13 members, focuses on both fundamental and applied topics in optometry and vision science, and we have international collaboration on clinical trials and also develop patents in refractive lenses and intraocular lenses. Our key research areas include refractive errors and myopia control, ocular surface and contact lenses, color vision, visual optics and also retinal electrophysiology. We are dedicating to improve and advance optometry and vision science and make an impact in both academia and society.
At the Science of Vision and Color Lab, we create databases of hyperspectral data of physical stimuli of the real world to provide optimized solutions for improving the color vision of natural objects, paintings and human skin. We use psychophysics, spectral manipulation and artificial intelligence to enhance the perception and visualization of natural objects important in museums, industry and public health.
At the Visual Optics and Ophthalmic Instrumentation Lab, we intend to evaluate the impact of ocular accumulation, refractive errors and age in the on-axis and off-axis optical quality by measuring in real time wavefront ocular aberrations. These results are convoluted with the morphological changes of the crystalline lens in real time, measuring with an optical tomography towards enhancing the individualization of eyesight.
I'm doing a PhD in optometry and vision science. At CER Lab, we collaborate on research into factors associated with the ocular dryness and dry eye, studying the best solutions to improve the quality of life for the patients with these conditions. The study of these factors, along with the development of new scleral contact lenses, is important for improving both vision and ocular surface health.
And we are working into the clinical and experimental optometry research laboratory. We are part also of an international training network called OBERON, which means Optobiomechanical Eye Research Network. And our work is mainly focused into developing physical and statistical models of the human eye to obtain a better understanding of the image formation of the human eye, being focused into the periphery and also the effects of accommodation. And this is important to obtain and to improve the different strategies that exist for vision correction.
The research group Physics of Quantum Materials and Bio-Nanostructures incorporates 21 integrated members. The focus of the overall research is development, both at the fabrication and theoretical levels, of quantum materials and bio-nanosystems and their applications in nowadays society. Applications range from biomedical, such as biosensing, bioimaging and localized therapy, to environmental, specifically in photocatalytic remediation and hydrogen photoproduction. The research team has complementary skills in condensed matter theory, modeling and ab initio calculations such as DFT, nanomaterials, biophysics, photophysics, and ultrafast optical techniques.
I'm a researcher from the Center of Physics of Minho University, and I work with polar cooperative phenomena in the electrics and also ferroelectrics and magnetic materials. I study in particular polar cooperative phenomena involving the interconnection with strain and magnetic properties and how they are intertwined between each other. I study mainly low-dimensional materials in the form of thin films and nanofibers. The thin films are produced by laser ablation, nanofibers by electrospinning, and we do mixing of materials, for example, creating bilayers, and then using the substrate-induced strain to change its polar magnetic properties and study its dynamical, magnetic, and electric behavior. In terms of nanofibers, we have done composite materials involving organic inclusions like dipeptide materials with strong piezoelectric and non-linear optical properties, and we use it for energy harvesting and non-linear optical conversion. We have also developed composite materials in composite nanofibers involving also magnetic materials that we have developed for energy refrigeration using the magnetocaloric properties.
I'm studying condensed matter physics. So in this lab, I'm doing pulsed laser deposition with the 3-calcium dimanganese heptoxide thin films, and I'm using strontium titanate substrates. So with the laser, we are striking the target, removing and transferring the material from the target to the substrates. And then I use the thin films to study the dielectric and magnetic properties of the films. My main goal is to change the nil temperature of the 3-calcium dimanganese heptoxides to high temperatures to apply in devices at room temperature. So I start my master's here in University of Minho, and I start working with the pulsed laser deposition and the dielectric properties. But to continue in this field, I choose to study here again in University of Minho, because here in the Center of Physics we have these facilities and this equipment that is difficult to work in another places and another universities. So here I have this opportunity. So I'm really liking to working here.
I'm a researcher here in the Center of Physics of the University of Minho. My research focuses mainly in the development of innovative supramolecular nanomaterials, multifunctional, such as hydrogels, magnetic and plasmonic nanoparticles for therapeutic applications. In particular, cancer is a disease that has a huge impact in the society, and as such, our objective is to improve the therapeutic efficacy, the person's quality of life, and to make the treatments more affordable. In this sense, the Centro of Physics provides a multidisciplinary team, the conditions to carry out this research, and also the possibility of establishing cooperation with different institutes that help overcome the challenges that we face to deal with our objectives. Besides that, we are strengthening the interaction and with the industry so that we can ensure that the biomedical solutions that we develop can reach the people that need them.
I'm new there. I arrived there more or less 1 year ago. So my research centers on orbitronics in 2D materials. And orbitronics is an orbital analog of spintronics. Spintronics has been here for a while and uses the spin of the electrons to storage and manipulation of information. But for many applications, it relies on heavy atoms with strong spin-orbit coupling, which are very expensive to extract and detrimental to the environment. So orbitronics offers an alternative by using the orbital angular momentum of the electrons in light and abundant elements like chromium and titanium, and this opens the possibility of a more environmentally friendly and cost-effective set of innovations. So by bringing a new field that's here, the last experimental results arrived maybe not more than 2 years ago to Centro de Física, we have the opportunity to lead this research field, especially in 2D materials, not only in Europe but in the world. It also opens the possibility of integrate these new fields with the field that already exists in the center, for example, in 2D materials and also in optoelectronic in 2D materials as well.
My name is Mike Belsley. I'm an associate professor here at the Center of Physics at the University of Minho, and I'm responsible for this laboratory. We're very proud of the work our students done. For example, behind me is a scanning second harmonic microscope that is able to analyze things in terms of polarization. Back behind the table, there's another second harmonic microscope that's wide field that can take images of large areas. And then we have a lot of different kinds of parametric amplifiers and white light sources that we use to do pump probe experiments and so on. And we're really proud of what our students learn here. They actually get down and build things themselves and rebuild oftentimes, and they have to put together different kinds of experiments. Well, that's something that that we're quite proud of.
I'm a professor at the Department of Physics, Universidade de Minho. I did my PhD, so my background in atomic physics. I did my PhD in France in the Institut d'Optique, in the group of Alain Aspect. So I believe photonics today is a very important field. Has many applications in our lives. There are many applications also in metrology, in quantum computation, and in many other detection of gravitational waves. So it's a very important expanding field in science and technology. Here at the department and Center of Physics, we had already some projects in called atoms and atomic metrology, which is related to optics and optical metrology. And we aim to revive those projects and to get some help from institutes across Europe, and in particular with the Institut d'Optique in Paris, to try to develop a group in metrology, both in optical metrology and atomic metrology. That I think it's very important for the technology, and could put Portugal in the map of this very important field. The interchange of students with other institutions is very important. We did this. There are some students that we send from here to France, and there is one very important researcher in Paris that was a former student and is developing a very nice work, Rafael Lopes. And this is a very important thing to do, is to try to form students here, to train them and to send them to these labs across Europe and even further off Europe, to try to build human potential to one day bring them back and to collaborate, and to bring them here to collaborate with us and to grow this specific field. We also have some collaborations with the industry, local industry like Bosch and Leica, to develop some instruments which are very important from the interchange of knowledge between the university and the local companies. And also to train students. Some of the students were even hired by these by these companies, and we have a close connection with them, which we want to strengthen in the near future.
At the Center of the Physics of the Universities of the Minho and Porto, my work is focused on the development of the sustainable advanced and multifunctional polymer-based material for sensor and actuators, energy harvesting and storage applications. Concretely, of the energy storage applications, my work is focused on development of the polymer-based membrane, solid polymer electrolyte, and the electrodes of the anode and cathode with the scope of the digital and sustainability transitions.
I'm a researcher at the Centro of Physics since 2020, and I'm specialized in developing thin films for biomedical sensing applications in 3 different areas. My main area of expertise is biocompatible thin films for sensing application, where we prepare thin films based on titanium matrices and we deposited on flexible polymeric substrates. These films are prepared by PVD magnetron sputtering using the glide technology, and with this we can optimize the films, the electrical, mechanical and chemical properties that will be essential for e-health monitoring systems, combining monitoring like EMG or ECG and functional electrical simulation. I also started my research in triboelectric nanogenerators. Currently I'm leading one project with the University of UT Austin, and these nanogenerators will be used to harness the energy of the body movements and supply the sensing systems that I've designed, making them more efficient and sustainable. And also, at last, but also in the medical field, I'm working in electromagnetic radiation shielding that will be used for protection for the healthcare professionals, but also for the electronic communication used on smart wearables.
My work focuses on developing new multifunctional biomaterials and strategies for active tissue engineering and cancer therapies. In addition to researching these biomaterials, I studied the interface between them and cellular tissues. I investigate how different stimuli, such as the mechanical and electrical, influence the cellular behavior, since these stimuli are present in the human body. To achieve this, I also design bioreactors that create more biomimetic microenvironments which are favorable for the cell growth and differentiation.
I was a student here at my university. I did my bachelor and master's degree here, and now I'm going to do my PhD at Institute of Optics, which was fortunate to have the Nobel Prize awarded to Alan Aspect, which is a member of the institute. And I'll be working on his group for the next 4 years. So here at my university and at the Center of Physics at Minho, I learned a lot, and especially I learned enough so that I can do a lot of different tasks, even in areas that I did not work on during my master's. And the proof of that is that although I didn't do atomic physics in my master's, I was able to easily adapt when I went to Institute of Optics to work there and to prove myself to them, which are more experienced in the field, that I was a capable student to do whatever they want. And I had to do a lot of things, things I had never done, from simple stuff as electronics to more advanced techniques on atom cooling to cool atoms and create Bose-Einstein condensates. So I think the main motivation to go there is to do something different, something that will have a bigger impact in the future. Especially when you look at the conditions in Portugal, where there's not so much experimental physics, the prospect of having someone doing a PhD in an institute that's very famous for what they do, with high expertise and high qualified knowledge, then in the future, when I come back, I will be able to share this knowledge and make a contribution to Portugal. And Well, probably, and I would like that to be so, to advance the field of atomic physics also in Portugal, which is important with the quantum revolution that we see nowadays.
The functional and smart materials and surface for advanced applications research line is focused on the development and application of novel materials for emerging technologies. These materials have high potential to be applied in renewable energies, in gas sensing, biological sensing, construction and building materials, and electronic and magnetic devices. We have a strong focus on improving the performance and durability of these materials under extreme conditions. The ongoing work in our research line encompasses the in-depth study of novel materials with tailored physical, electronic, magnetic, mechanical and optical properties, for example, for enhancing the efficiency in solar and thermal energy conversion, and also in photoelectric catalysis. A significant attention is also provided to designing materials for sustainable technologies. Our research line has 24 members with a PhD, including some young scientists which are already paving their way with new enticing projects with a high societal and industrial impact.
Currently, we are working on novel materials for autonomous IoT sensors. In the framework of this topic, we currently got approved the Marie Curie doctoral network. The aim of this doctoral network is to train 12 doctoral candidates on advanced materials characterization, fabrication and simulation techniques. To do that, we will collaborate with top research universities, institutes and companies. So the groundbreaking idea is to substitute batteries which have a short lifespan and also need replacement. So our idea is to use energy storage, energy harvesting architecture coupled with low power onboard processing electronics. Particularly at the University of Minho, we develop ferroelectric most compatible oxide thin films. And the idea is to use them for sensing, energy storage and low power non-volatile memories. To do that, we use state-of-the-art techniques currently available at our center, such as pulse laser deposition and ion beam sputtering deposition technique, and then we characterize the physical properties of the materials. So the main purpose is to nano-engineer binary oxides such as zirconia and achieve high-performing energy storage capacitors, self-powered photodetectors and low-power electronics. To complement our work, we also work with a theory group in our center that uses material simulation tools to predict and understand the behavior of our materials.
So my name is Eduardo Castro and I'm presently coordinating the line 4, research line dedicated to theory, in particular quantum physics and fields both in high energy and condensed matter. And our range of research topics go from, for example, conformal field theory to topological quantum matter and 2D materials. We are based at the University of Porto. The majority of our members belong to the University of Porto, but we have also members, theory members from the University of Minho, and we plan to include even more members from the University of Minho in the near future. So we use both more oriented analytical approaches like the non-perturbative bootstrap, more related to high energy physics, and also high-performance computing simulations, like where we use software, like the one developed in the KITE collaboration. I'll give you two research highlights on the high energy side. So we have been members of this prestigious collaboration. International collaboration on the non-perturbative bootstrap funded by the Simons Foundation, and we have recently been awarded a cost action project also in this topic. On the more condensed matter side, particular 2D materials. We have long experience with graphene, which allowed us to make, I would say, relevant contributions, publications to this recently established and hot topic research line on marine materials. So we are actually very proud to say that we have recently accepted the Nature Physics paper, where we have shown theoretically that quasi-periodicity is an important ingredient, actually an extra knob that you can use in marine systems. This publication is very interesting in many different aspects. One of them is the fact that it involves collaboration with other theory members of this research center in other research lines, but also theorists from other research centers belonging to the associated laboratory, of which our center is a member.
My main focus on research is on developing of numerical algorithms, numerical methods to be applied in the quantum transport and electronic properties of big systems with disorder. I also have a good collaboration with our colleagues of high energy physics, where we develop also numerical methods to the study of properties in the quantum field theory. As a part of our research activity, we have international collaboration with other universities on the development of open source software named Kite, precisely devoted to the computation of electronic properties using high performance computing, and that is able to achieve very big system sizes to compute precisely the property that is induced by disorder. I also have an important role on the management of the HPC resources inside our center and on the education of the young researchers, of PhD students.
I was the director of this center for almost 10 years, starting in 2008, and now I help as a deputy director. Looking back, important moments come to mind, such as the decision made in 2014 about the merger with the Physics Center of Porto. The goal of this was to achieve a balance between applied and fundamental research, theory and experiment. I also recall the work on reorganization of our center so that it would work in fewer research areas and more focused, and the struggle for a more fair assessment of the results of our evaluation in 2015. An important step was made in 2021 when we became part of the Associated Laboratory for Materials and Emerging Technologies, which also includes centers from Porto and Lisbon. But the most astonishing fact to me is that we still produce excellent and sometimes outstanding scientific results and raise excellent young scientists despite the many years of underfunding and absence of investment in facilities and infrastructure, a sad reality of much of Portuguese science.
Concerning the period of after the previous evaluation, while I was the director of the research center between 2020 and 2023, global results show an increase of the scientific productivity with an increase of the number of papers and an increase of the average value of impact factor, which shows an increase of the visibility of the center. These results can be associated with an increase of number of PhD students and young researchers. although we had a decrease in the number of integrated members. Concerning to the funding, we also had an increase in total funding when compared with the equivalent period before the previous evaluation. The Portuguese agencies continue to be the main source of funding, and we continue to have European Commission funding relatively low. We did some efforts to change it, increasing the number of applications and the use of large European scientific infrastructures, which results in the number of publications with co-authors from foreign institutions, which shows an increase of the internationalization. I would like also to point out the creation of the associated laboratory, the Laboratory of Physics for Emerging Materials and Technologies, with other two research centers, the IFIMUP from the University of Porto and the CEFEMA from the University of Lisbon. Finally, as already verified in previous evaluation, we continue to have a low or even inexistent laboratory technical support and high bureaucracy contracting processes, which have been too time consuming. As a conclusion, I would like, or I think, the performance of Centro in this period improved when compared with the equivalent period of previous evaluation.